So welcome everyone. So my name is Chiranjeev. I'm a faculty member in the ECS division. So I'm also happen to be the chair of CS department. So you've organized this event for all of your benefit. So I think the most important part is there is, as you can sense, that there is a lot of confusion of merit of doing PhD. And of course, our intention is that to pursue PhD in our institute. But before that, we wanted to just have a conversation with all of you students to see why there is value in still doing PhD. And let's see. Hopefully, after this session, we will be better informed. So, with this, I will hand over the discussion to my colleague, Professor Mayank. Mayank.
Thank you, Chiru. Very good afternoon to everyone and a warm welcome. Let me first acknowledge all my colleagues here who are joining this call from different departments of the division of ECS in Indian Science. We have Himanshu, Sudan, Chaya from, and I myself from different departments. Chiru, Professor Chiranjeev Bhattacharya, he is the chair of computer science and automation. And then a couple of other colleagues who also joined from different departments as well as the chairs. What we are going to talk about is basically has been curated over last 1 month. We have been thinking about reaching out to students and potential PhD aspirants or aspirants who may or may not have interest in doing PhD. And basically, as our scientific social responsibility, start breaking the myth about PhD. Hopefully, we can touch some of you and your interest, and hopefully some of you may eventually think of pursuing PhD, whether at ISC or at other places. That is completely your call. Our purpose from this session is to ensure that you have the right picture of why PhD. On this note, let me start. So here is a quick agenda. We have limited time, otherwise we could have elaborated the agenda, we could have spent more time, but this is what we will try to cover in the first 10 minutes, the first 4 bullet points: why PhD, why one should do PhD and who should pursue PhD, and what are the global opportunities in general post-PhD from India. And in the next part, in 10 minutes, we'll talk about the PhD opportunities in ECS at ISC Bangalore. And we'll also have opportunity to listen to our PhD students in ISC and their journey from their individual places to ISC and why they decided to pursue PhD. So now I kind of created this list after say reading all kind of posts on social media, whether it is LinkedIn or Quora, and different kind of opinions students express at different forums about PhD. This may not be a comprehensive list, but I believe it's comprehensive enough to basically send a picture that there are a lot of myths about PhD, and there's a lot of apprehension and negativity about PhD, or lack of clarity about PhD. I will get back on these myths a little later, but let me first clarify a few things about PhD. And I'm really sorry if we are not very elaborate because of the limited time we are going to invest now. Often the question comes is, what is PhD? What is the process? And how is it linked to, say, publications? Publication is something which is a gung-ho topic, or a pressing point, often linked with PhD process. And we thought that it's good to use this platform to clarify some of these things, and we'll be happy to elaborate later. For example, PhD is not a degree program. Often it's seen as a degree program, or a low-paid job. PhD is not a degree program. PhD is not a low-paid job. PhD is a training program where you are asked to invest your time and energy to basically train yourself to become an independent researcher. Now, I'll elaborate later what is this independent researcher business. Now, a PhD degree is granted when you demonstrate your ability to research independently. Now, in this whole thing, you can see that there's no no time limit defined. A PhD can be given in 2 years, a PhD can take 5 years or 6 years. It all depends on how fast you can train yourself to become an independent researcher, and how fast you can demonstrate your ability to basically research independently. Now, in this process of demonstration that you can conduct research independently, initially, you work under very close guidance of what is called as your PhD supervisor. And eventually towards the end, you start working almost independently. So basically it's a stage wise training process. In the beginning, you work under close guidance where every step is guided by somebody. Then you become a co-worker of your PhD supervisor, and then towards the end, you work so independently that you start basically coming up with things that your supervisor starts learning from you. And the stage when your supervisor starts learning new things from you, that is the stage when you demonstrate your independent research ability, and that is the time when you can be awarded a PhD degree. Now, as you can see here, the end has no fixed timelines, right? It can be 2 to 3 years. Some people may take 4 to 5 years. Some may take even longer. It all depends on the nature of problem, the area, individual's aptitude to pursue independent research or research, and analytical ability to explore and ability to get trained in these directions, right? And these are the abilities that we try to test during the PhD interview. So again, there's a misconception about PhD interviews that you are tested on how much depth you have acquired from textbooks and so on. All of that is needed, but you are mostly tested for your aptitude and ability to explore, and how much you can explore independently. Now, in the process of conducting research and later conducting independent research, you discover, innovate, invent, or find answers to some fundamental unsolved questions. And so when you have discovered something, innovated something, invented something, when you have found answer to some fundamental unsolved questions, you start communicating your finding with the outside world, and this communication basically transforms in, it results into what is called publication. So basically you can say that a research paper or a publication is nothing but a byproduct of the communication that you do with the rest of the world about your discovery or invention or innovation. Now, again, often there's these myths: how many paper one has to publish? One paper is mandatory, two papers are mandatory. Again, there's no limit on how many papers one has to publish. One impactful paper is always infinitely times better than thousands of useless papers. Sorry about the background noise. Now, the impact of a journal does not decide whether the work is bogus or impactful. As a starter, you may want to look at where the best minds in your specific area publish. Now, let me also point out that if you read these 5 bullet points carefully, the point 1 is the definition of PhD. Point 2 is the core of what is a fundamental requirement. Point 3 is the process one has to go through. Point 4 is the byproduct to justify you have gone through. 3 to justify 2, whereas point 5 only clarifies the limit. Now the question is why one should do PhD, right? I mean, I think the first bullet point is clear to you. This is to train yourself to become an independent researcher. But there are many other aspects as well. For example, this is to train yourself, this is to learn how to solve a problem independently. This is to learn how to master an area independently, right? I mean, today you may become a master in your PhD journey may make you master in one area, but you should also learn how to become master in other areas independently. You will not have a PhD supervisor for your whole life, but that PhD process will also train you to basically master other areas independently, solve other problems independently, right? Research in other areas independently, to acquire expertise in a field which is far more phenomenal than the other peers you might have at this stage, right? Again, to push yourself to be counted among the few handful experts around the world. For example, to get an exponential career path, to tap into a number of academic and industrial opportunities, to grow as a leader in a given field, right? I mean, the list goes on. There is no limit to this list, but I hope this gives you a quick overview of why one should pursue PhD. Now the question is, who should pursue PhD, right? Is everyone, anyone who has good academics eligible to pursue PhD, or should be embarking on pursue PhD? I mean, I would say good academics is the starting point, but if you want to assess whether you are made to pursue PhD, you want to look into following bullet points. You want to see whether you are curious and are willing to explore, right? That addresses the what part of PhD. You want to see whether you are critical about anything and everything around the world. Those who are willing to ask questions are a good fit for PhD. Those who are willing to get into the depth and learn complex skills are basically born to do PhD. Those who are willing to uncover, explore unknowns, those who are willing to take risk, try out unknowns, is something worth pursuing. People who must pursue PhD. And over and above these points, those who have an urgency to explore discipline in work and life and a sense of detachment to be engaged in research 24x7 are those who should be thinking of pursuing PhD. But again, while I said 24x7, that does not mean that you are going to be stuck in lab for 24x7. It's a mental bandwidth to be occupied in the problem that you're working on, is where the 24x7 engagement comes into picture. Now, the global opportunities in general post PhD in India, you will have opportunities. I mean, a good PhD will have many opportunities. Let me put this as simple as that possible, right? So you will have opportunities in academia. I mean, if you have a good PhD, you can get direct faculty positions, or you can pursue postdoc and then you can embark on a faculty position. You will have opportunities in industry. So there are direct industry positions in India and abroad. Then you can also pursue postdoc and come back to industry. So all kind of mix and match are possible, right? It's not that you pursue postdoc and then you only have to go for an academic position. You can always come back for industry position. Then government labs and R&D. There are several government labs and R&D labs which are looking for PhDs, both in India and around the world. Startups is something that a lot of PhDs are looking for. So those who are in engineering fields, for example, and if you come up with something really unique, which can touch the market, startup is certainly something that is worth pursuing. And again, startup is not something that, once you are in startup, once you start a startup, then you cannot come back to something else, right? You can get into a startup, you can have your own startup, you can always change your path later on if your startup does not work, or if you like to do something else, right? So PhD offers you that training. PhD offers you training to an extent that you have flexibility to change your directions and path in highly independent fashion, compared to any other training that you get, say, till masters or BTech, right? Now, another point is that in industry, PhDs are usually paid better than MTechs. That's also a myth, that PhDs are not paid better, or PhDs only have academic positions available. So PhDs are paid better than MTechs, certainly BTechs. And beside, their growth is always, either linear or exponential or super linear. I mean, the point I'm trying to make is that while those who those who limit their education till masters and BTech, majority would have a stagnant growth beyond a point. But the same is not true for PhDs. PhDs career never stagnate, even after many years. Now let's come back to the myths. I'll not be able to elaborate all of this, but I only want to say that these are myths. For example, PhD, you do PhD only if you don't get a job. That's a myth. That's not true. I hope I have made clear who should be doing PhD and who have those skills, aptitude, and they should be doing PhD whether they have a job or not. PhD can only become a professor and don't have much of the opportunity industry. This is also not true. In fact, getting an academic position is much more difficult than getting an industry position. Industry position is rather easier than getting an academic position. Fellowships such as PMRF are not transparent. That is also not true. ISC hosts a lot of PMRF. In fact, majority of the PMRF in the country are in ISC, and we have never complained about and our students have never complained about the transparency. If you do good, if you have a good academic background, if you write a good proposal, you will certainly get some of these national fellowships. Stipend is not enough for gaining financial independence. As I explained, PhD is not a job. So financial independence is not what you should be looking for during PhD. PhD is a training program and you are asked to invest your time and energy during PhD. And once you do that, the amount of money you may lose during PhD, in case your other fellow colleagues from masters or BTech would have earned certain amount of money, you are going to recover all that loss in the first 1 or 2 year of your industry journey, and you will save much more afterwards. Now, again, think twice leaving industry job for pursuing PhD. Again, that's a myth. You should pursue PhD if you want to pursue PhD. Industry job has nothing to do with whether you want to pursue PhD or not. PhD is not an extended project work. As I said, PhD is a training program. PhD is again not a research job with zero payment. PhD is a training program. It gives you a stipend to survive, right? Again, there's a misconception that PhD students need to raise funding and there's a funding shortage. That's not true. PhD students don't need to worry about funding. Their advisors raise money, they build up, and the PhD candidates only need to focus on working on a research problem given by their advisor or their institute. MTech is a must for PhD. That's also not true. The BTechs can also join for PhD. There are different ways through which BTechs can join for direct PhD. Either they come through GATE or they come through CFTI. The details are on ISC admissions page. PhD means publishing papers. Again, that's not correct. PhD is a training program. Publishing is a byproduct. PhD takes too long, 5 years or more. I think I have explained this earlier. There is no time limit for this. It all depends on how fast you can train yourself to become an independent researcher or explorer. Your 5 years will be wasted if you don't get results and papers. That's also not true. In 5 years, you learn a lot of skills. And these results and papers are only byproduct of your explorations. Your PhD is not granted for you to publish papers. Your PhD is granted for, when you demonstrate your ability to explore independently. So that's not wasted. PhD is in India is different from doing PhD abroad. That's also not true. Doing PhD in India or abroad, they all are same. The quality of PhD varies from institute and the group. It heavily depends on the group than the institute. So you have to choose your group wisely. And then again, people think that I have an industry experience, so I should get into PhD without any hustle. That's also not true. Industry experience, the skills that you acquire in industry are different than the skills that are tested during the PhD interview. So industry experience is good, but it's not that does not mean that if you have industry experience, then you have easy get into institutes like ISC. PhD is all about bookish ideas and they lack hands-on experience. That's also not true. In PhD, you basically work on some of the most complex tools, softwares, hardwares, develop skill sets which are not so easily available in industry and not so easily available after BTech and masters. So at PhD level, you certainly develop a high level of hands-on experience, which are of high value both in industry as well as in academia. Also, often the fresh MTechs or BTechs feel that they should first gain some work experience, then think of PhD. That's also not true. Your work experience, while may make you an efficient worker, but that's not a mandatory requirement for doing PhD. You can always pursue PhD immediately after your BTech or MTech. So on this note, let's move on to the next module of the session, which is PhD opportunities in ECS at ISC Bangalore. Chiru, you want to add something at this point before we move on to individual presentations?
Thanks, Mayank. No, I didn't want to add. I think you covered it well. I think I have nothing more to add at this point. Thanks.
Okay. So, so the ECS division consists of 4 departments. ISC has many departments, and all the departments are grouped into a few divisions. ECS is one of these divisions, which basically cover all areas under ECE, EE, and CS. We have 4 departments: Department of Electrical and Communication Engineering, Department of Electronic Systems Engineering, Department of Electrical Engineering, and Computer Science and Automation. These 4 departments collectively work on, they all work together, and they collectively work on pretty much all areas which fall under EE and CS, broadly EE, CS research areas. So I represent electronic systems engineering. So I'll talk about electronic systems engineering, and then my subsequently my colleagues will talk about their respective departments. So in electronic systems engineering, we broadly work on 4 different areas. Area 1 is nanoelectronics, microelectronics, semiconductor physics, solid state physics, where we work on experimental nanoelectronics and nanoscience, computational nanoelectronics. So we work on range of technologies, semiconductor technologies, from advanced CMOS to gallium nitride, 2D materials, sensors, and so on. Then the other area is VLSI design and sensors, where we have colleagues who work on a range of VLSI design and sensor topics, VLSI design topics such as analog, digital, neuromorphic, machine learning, VLSI design for cryptography, hardware security. Then we have sensor area, sensors for silicon photonics, NEMS, biomedical sensors, and so on. Then we have colleagues who work in power electronics area. Broadly in power electronics, people work on wide bandgap semiconductors, silicon carbide, high voltage silicon devices, power electronics for motor drives, photovoltaics, as well as automotive vehicles or electric vehicles. And the last area is SPCOM and CPS, so signal processing, communication, and cyber physical systems. So we have colleagues who work on wired and wireless networks, communication protocols, algorithms, cyber physical systems, robotics, mechatronics, signals and information processing, quantum information processing, and as well as within nanoelectronics, I missed to talk about the quantum computing part. Chandramurthy, over to you.
To keep things simple and not make this an information overload for you guys, what I will do is to very high level summarize at a very high level some of the research activities that happen in the ECE department. The 3 broad areas: the first is communication networks and cyber physical systems. The second is signal processing and machine learning. And the third is RF, applied electromagnetics, photonics, and nanoelectronics. Within each of these areas, we explore topics, a variety of topics. And essentially, if you look at what is the up and coming interesting research that is happening around the world in these areas, the ECE department pretty much has a footprint there as well. And we also continue to work on classical areas such as wireless communications and coding and information theory, or antenna design, or signal processing for communications, and so on. But we also have significant work in other up and coming areas such as quantum communications, social networks, 5G and beyond, going on to 6G communications, compressive sensing, graph signal processing, machine learning, digital health, and CMOS for RF, and integrated photonics, nanomaterials, devices, sensors, and quantum technologies. One very recent breakthrough research was from one of my colleagues, Kaushik Majumdar, in the area of quantum technologies. It was a news article and so on. So if you're interested, you can Google Kaushik Majumdar and find out further information. That's it from my side.
So yeah, so this is Sudhan from Department of Electrical and Communication Engineering. And we are also having several labs for the mentioned topics by Professor Chandramurthy. So some of the pictures we have given from the test bench for radar on chip. And also we are having 5G test bed at ISC, and we have shown initiation for this 5G communications. And also we are having millimeter wave 5G communication test bed. And we are also having nonlinear optical microscopic laboratory indoor visible light communication setup, and also V2X platform, LT-based test platform. And recently, we are also initiated for several projects for 6G communications, such as for non-orthogonal multiple access, intelligent reflecting surface, and also the communication for high-speed mobility, such as OTFS communications. And also we are looking for security for 5G and 6G communications. Yeah, thank you very much.
Vishnu, over to you.
Thanks, Mike. So warm good afternoon, everybody. My name is Vishnu, and I'm a faculty member in the electrical department, electrical engineering department. So just to give you a background of the department, the electrical engineering department is one of the first few departments that was started at IISc. And over the last 100 years, the department has contributed significantly to the growth of electrical engineering research and education in India. If you look at the kind of research that is being carried out in the department, you can loosely divide that into two categories. One can be thought of as the traditional electrical engineering fields, such as power electronics, power systems, and high voltage. And the other part can be thought of as system science and signal processing. And if you look at the faculty members, roughly 50% of the faculty members work in the traditional area, power electronics, high voltage power systems, and roughly 50% work in system science and signal processing. And just to give you a flavor, so these are the 4 research thrusts in the department. And just to give you a flavor of what is going on in these individual areas, power electronics, again, the faculty in the department work at all cutting edge applications of power electronics, including advanced wide bandgap semiconductor device-based power converters, power electronic converters for applications such as electric vehicles, electric aircrafts. Then we look at, let's say, DC microgrids, AC microgrids. So you name it. I mean, and power electronics, it's a very broad area. Right? I mean, you can think of power converters ranging from a few watts to even hundreds of kilowatts and megawatts. So the faculty work across a wide range of spectrum. Then if you look at power systems, actually the department is one of the pioneers in the country in initiating research in this area. So in the 60s and 70s, many of the transmission systems were designed for the first time by this department. And the faculty in this area work on, again, a wide range of topics, such as power system stability, dynamics, computer-aided protection, and design of distribution systems, FACS, microgrids, and economic dispatch. So all kinds of problems in power systems. And one of the recent focus has been looking into cyber attacks in the power system. So how can we make our power systems much more robust by looking at cyber security aspects? So that has been one of the modern research trends. And then the high voltage. So again, the high voltage research started in the 1940s, and the department is a pioneer in the high voltage research. And in the slide, I'm showing a picture, at least a snapshot of the high voltage lab in the department. So it's a one-of-a-kind lab with very unique testing facilities. And the faculty in this area work in a wide range of problems. They look at, let's say, insulation studies, high voltage electromagnetics, computational electromagnetics, then lightning related studies, then protection, EHV, UHV, power transmission, corona, so substation insulation design. So again, the faculty in this department have contributed to several high voltage installations in the country. And finally, coming to the system science and signal processing, again, the research in this area started some of these terms such as machine learning, artificial intelligence, they are cool. I mean, we have started hearing those terms in the last, let's say, 10, 20 years. But the research in the department goes way back. It started in the 50s, you could say. And again, the research kind of started, in the olden days, it was more rate control, adaptive control. Then that research evolved to learning and pattern recognition. And this is one of the few departments where we conduct research on medical imaging, biomedical imaging, and image processing. So this system science, it cut across a variety of disciplines. So it's highly interdisciplinary. It involves all sorts of, let's say, signal processing, which can be speech processing, image processing. And again, the faculty recently conducted a lot of work during this COVID. So how to use these kind of signatures to detect, diagnose whether somebody has COVID. So that is one of the recent developments. And again, we have faculty who look at topics such as computer vision, artificial intelligence, machine learning, etc. And robotics and control is another area where some of our faculty focus on. So that is pretty much about the department. So if you would like to find more information, please go and look at the departmental website. Thanks, Mike.
Thanks, Vishnu. Chaya, over to you.
Yeah, thank you, Mayank. Hello, everybody. My name is Chaya Ganesh. I'm a faculty member in the Computer Science and Automation Department. The activities in the CSA department is roughly divided across 3 research streams: theoretical computer science, computer systems and software, and intelligence systems. In theoretical computer science, there is research across a wide range of sub-areas like algorithms, complexity theory, cryptography, graph theory, algebraic complexity, lower bounds, approximation algorithms, bin packing, knapsack, online algorithms, and so on. And in computer systems and software, we have faculty working in sub-areas like programming languages, compilers, software engineering, multi-core programming, database systems, security, distributed computing, etc. A lot of these research activities, we also have examples of some of these research resulting in technology transfer, startups, etc. And in the intelligence systems stream, we have research in areas like game theory, mechanism design, data mining, reinforcement learning, stochastic control, and cognitive systems. Having said that we have these 3 research streams, we also have a lot of interdisciplinary work across these 3 streams, things like cryptography and system security, interdisciplinary work between intelligence systems and theory, and so on. I encourage you all to go look at the department webpage if you're interested in any of the details of these research areas.
Thank you, Chaya. I think we have now covered first two modules, and I would now request our student representatives from different departments to take 2 minutes and talk about their journey to ISC and what motivated them to pursue PhD.
Yeah, thanks, Professor Mayank. So my name is Yashwant, and I'm a direct PhD student at the Department of EC at ISC. So by meaning direct PhD, I mean I came to PhD program right after my bachelor's. I completed my bachelor's from NIT Trichy in Electronics and Communication Engineering in 2020, and since then I'm with the Department of EC as a PhD student. So I'm currently working on some problems in signal processing for communications with some special focus on wireless communications and so on. So to give a bit of my reason to come for PhD is that I mean I had a good motivation to do or to pursue research from my BTech days, where I gone through several fundamental courses and some of the specialized courses as well, where I became more passionate about learning more about the depth and the nitty-gritties of every concept. So that kindled my passion towards research. And I mean, at the outset, I also wanted to do something, so that I can do some contributions to the technical society in the concepts, classical concepts that are already available, and also do some innovations. So one other advantage which I thought of in my mind, I would get for going a PhD is that I would explore, or rather the curiosity to explore more would be the point that kindled or motivated me to PhD. And I can learn many things at depth. Also I can work on futuristic problems. I think this is one of the points that distinguishes or highlights the superiority of a PhD program, because unlike industries where you get to work on the problems that are dictated by people in positions or the contemporary industry requirements. In research area, at least in PhD, which is more of an academic research program, we get to work on futuristic problems. In fact, I myself did not opt for placements during my bachelor's. So so in fact, PhD also have a lot of lucrative fellowships, like Professor Mayank mentioned, and I myself the recipient of a couple of fellowships here. So yeah, I think so. This is about myself, and I strongly encourage all of you who have the curiosity to learn and explore more to go for a PhD program, and it is certainly worth it. And yeah, I think that's it from my side.
Wonderful. Thank you. Can we have Harsh? Harsh?
Yeah, hi. I hope I'm audible. So this is Harsh. I am a PhD student in the Department of Electronic Systems Engineering. I am working with Professor Mayank Srivastav. So my journey so far, actually, I did my bachelor's and master's. I integrated BTMT program. I did that from IIT Kanpur. I completed that in 2021, and after that, I immediately joined in the PhD program at IISc. So during my final year, that is the MTech year, I applied to different core sector jobs in the electronic industry, and simultaneously also applied to different PhD positions at different places. My ultimate motive was to work on research on devices. I wanted to work on research on electronic devices and wanted to gain expertise in that. So I applied to all of these positions, and then during this whole process, I got a PhD position at Professor Mayank's lab in ISC, and then I started working here. Now, why did I join the PhD program? First of all, I wanted to gain expertise on research on devices. Secondly, at Professor Mayank's lab, there are different opportunities, different facilities available. Everything related to research on devices can be done here, starting from fabrication, characterization, or computational modeling. So that was one of the important incentives. Second is PhD also has a flexible work hours. Over the last 5 years in BTech and MTech, I kind of got used to flexible work hours. Whenever I wanted to work, I worked, whether it be it early morning or in the afternoon or late at night, as long as the work gets done. So that was like why a PhD is like that. In an industry, there are fixed work hours where you have to work and you are detected by your superiors to do a particular job. But in PhD, while the overall broad topic is defined, the particulars are what you decide upon, and you work uh, um, at times when you decide. Uh, Besides that, one of the important aspects is the money aspect in PhD. So, PhD in India has like there are various fellowships available now. They are lucrative. They provide various stipends. There is Visvesvaraya Fellowship, PMRF Fellowship. Besides that, there are many research awards. If you do original work, you can go to conferences. You can also submit your work for different awards, and you get that money there. And there are also where research grants, which basically your professor, the supervisor works on that, and you get money from that. So overall, that is all I would like to say. Um, and it always feels good when you apply for a research grant and the fellowship, and you receive that. And that is all based on your work on PhD. Uh, that is all I would like to say here.
Thank you, Harsh. From my lab, I hope you meant the facilities in ISC. We can move to the next student.
Yeah. Hi, everyone. I'm Shruti. I'm a third year PhD student at CSA. I'm currently working with the theory group here. As for my background, I have done my BTech in computer science and engineering at NIT Warangal. So during which I have done an internship as a software engineer at Goldman Sachs Bangalore, and even in my final year, I had a software engineering job offer from the campus placements, but I was not interested in doing a software engineering job. So I knew about GATE. I knew about the master's program and the PhD program at IISc. So I gave GATE in my final year, and I also appeared for the MTech research interviews at CSA, and I got admission to both the master's programs. And I chose to go with the MTech coursework program. So this program consists of you requiring to do 40 credits, which can amount to some 10 to 12 courses, along with a project that would be mostly a research project. And since I wasn't sure whether I want to go for research or not, I thought the MTech coursework program was ideal for me. So in my first year, I have done various courses, and in second year, I worked with Dr. Anand Lewis for my master's project. And I really liked the research environment at CSA, and I decided to take an admission for the PhD program here itself. And I should note that there are many more like me who have continued after a master's program to do their PhD here itself. And my main motivation to do PhD is, like many people have already put it, it's just pure curiosity about how the problems are being solved. Just the process itself was really exciting for me, and I wanted to be a part of that. And my main goal was to solve some of the open problems in the areas like fairness and machine learning that I'm interested in, while having fun doing so. And during my PhD so far, I have published at one of the top conferences in machine learning, and there are some more works on arXiv. And I was fortunate enough to receive a Google PhD fellowship and a PMRF, out of which I chose the first one. So this comes with a generous monetary support, which allowed me to travel to various places across the world to attend conferences, summer schools. I also recently attended the Heidelberg Laureate Forum, which happens in Germany, and can meet a lot of laureates in computer science, like Turing awardees and so on. It was a really good experience for me. Yeah, so these are all the added perks of doing a PhD for me. Otherwise, it's just pure curiosity that's motivating me to do PhD. Yeah, if you have any questions, please reach out. Yeah, thank you.
Wonderful. So in the end, we have Himanshu. Himanshu, go ahead.
Yeah, good evening, everyone. I am Himanshu from Electrical Engineering. I am a direct PhD student here. I completed my bachelor's from IIT ISM Dhanbad in 2020. The main motivation behind me for joining the PhD program at IISc was like ever since my BTech, I have been passionate about becoming a very good engineer and contribute to the society by coming up with innovative solutions. So, and doing a PhD will give me the required skill sets, the training, and the exposure to be able to achieve my goal. So that was the motivation behind my joining PhD, and here I'm working on reconfigurable chargers for electric vehicle applications. And during my BTech, I also had some internship opportunities where I research internships where I interacted with PhD students. I was working closely with PhD students. So there I got a flavor of how exciting the life in PhD can be. So despite having a job in Vedanta through campus placements, I decided to pursue PhD at IISc. So thank you. That's all from my side.
Thank you, Himanshu. So we are at the end of our third module, and now the floor is open. We will spend some good time answering your questions. My colleagues will be joining me in answering these questions, or if there's a question addressed to some of the students, they will be answering those questions. So feel free to ask your questions independent of who you want to address to. You can address to faculties, to students. These can be any question, any type of question. Just feel free to ask whatever you have in mind, and we'll take it from there. So for questions, you are requested to type in the chat box, and we'll pick the questions from there and answer. So there's a question from Jatin. It's highly encrypted question. BTech-PhD versus BTech-MTech-PhD. There can be many meanings. Okay, procedure-wise, those who join PhD after BTech, they are required to do a little more in terms of coursework. So this is basically, if I tell the number of courses, so in terms of number of courses, it's 8 versus 4. So it's 1 semester extra coursework needed for those who join after BTech. And other than that, there's no difference in terms of the requirements. So in some sense, you are saving 1.5 years, but I would say you are actually saving 1 year. MTechs come with some level of training on various tools and skills needed. BTechs don't come with those trainings, so those trainings are also offered. So in a sense that if you join directly after BTech, you save almost 1 year before you complete PhD. ISC also offers an integrated PhD position, which is if you have done certain number of credits, you get both master's and PhD degree, which means you don't lose anything, you only gain 1 extra year. And that 1 extra year can be invested in many things in future. The difference between MS by research and PhD. Chaya, you want to answer this?
Yeah, sure. So the way I think about it is MS by research is a research program that's for a shorter duration. You know, if you're sure that you want to get a taste of doing research, but you don't want to commit for a longer duration, then perhaps MS by research is a good idea. In terms of the work that you do in MS by research, typically you either solve one problem or a couple of problems that are closely related and write an MS thesis. Whereas in a PhD program, it's more like a journey where you go from solving problems that you're given to asking good questions yourself and becoming an independent researcher. So it really depends on what you want to do, what your goals are for after your degree. If you feel like you do want to try doing research, but you're not very sure if PhD is good for you, then you can enroll for an MS by research program, which is a good sort of intermediate point. And if you have fun doing it, you can upgrade to PhD or finish your master's and enroll for PhD and so on.
Just to add, you can also request for conversion from MS by research or MTech to PhD. At least in ISC and some of the top institutes in the country, this conversion process exists. So what are the opportunities to do a PhD while working in industry simultaneously? Maybe let me answer this. I saw some of the questions in the form. First of all, PhD is a full-time engagement. So there's no PhD while working in industry, except the external registration program or the sponsored program that we have. But even in that case, your engagement on a PhD problem is priority 1. So this is also a myth that you can PhD is a project, so you can take up one more project and you can continue working on your industry job. This is not the case. If you are working in industry, either you leave that job, come for a full-time PhD, stay in ISC for longer period, or if you want to be in your industry job and if your employer supports, then you can enroll for the external registration program. But even there, you have to commit for the entire coursework. After the coursework, your administration should give you enough bandwidth and time to work on your PhD problem. Usually, when we sign papers, we expect that the industry is committing their employees to be available at least for 50 to 60% of their time to work on the PhD problem. Right. So you think in this way that your PhD problem will become your full-time job, and your industry job will become your part-time job. Anyone else who want to add to this? Vishnu, Chaya?
I think you covered it.
Okay, great. So how about postdoctoral program at ISC Bangalore after PhD in field of biomedical signal processing, AI and ML? Vishnu, you want to take this question?
Yeah, so regarding postdoctoral program, I mean, there are different types of postdoctoral programs that are offered by IISc. So there is this national postdoctoral fellowship, and there are also institute level fellowships, such as C.V. Raman postdoctoral fellowship, Institute of Eminence postdoctoral fellowship. So those are all schemes, but you have to first identify a faculty who might be interested. So I would recommend you to get in touch with faculty who is working in the field of AI and ML, who might be interested about your background. So I'm sure that multiple research is
signal processing, AI and ML. So maybe you can tell about people in EEE who work on biomedical signal processing, in which Chaya can talk about people who work on AI, ML in CSA.
Yeah. So here there are many faculty who are working in the field of biomedical signal processing. So one is Professor A.G. Ramakrishnan, electrical engineering. Then there are faculty like Sriram Ganapati, who is working on speech processing. So there are multiple faculty who works in this area. So I would recommend you to get in touch with them. And maybe my colleagues can talk about faculty in other departments.
Right.
Yeah, in EC department also, Professor Pathus also working on AI and ML for biomedical signal processing.
Wonderful. Chaya, you want to add from the CSA point?
Yeah, so in CSA, like I mentioned, intelligence systems is an entire research stream, and we have several faculty colleagues working in AI, ML, and related problems. We also have some postdoctoral fellowships, like the IOE fellowship. I think you can check out the department webpage. The information is there, and if you think it's suitable, you can apply.
Great. In DAC, you should contact Professor Hardik Pandya and Chetan Singh Thakur, who work on biomedical signal processing, biomedical related topics using AI and ML. You can also contact Professor Shayan Srinivasa Garani, who works on signal processing and uses, have applications of AI and ML into signal processing. I would say more than 30% of EECS is now in AI ML and its applications in various fields.
Yeah. So just to
I wanted to know the difference. Yeah, Vishnu.
In electrical department, there are also Professor Prashanta Kumar Ghosh and Professor Muthuel. They also work in related areas. So you can consider reaching out to them as well.
So I wanted to know the difference with respect to coursework, duration, placement, and project in PhD, MS, MTech. Vishnu, you want to answer this, or anyone else?
Difference with respect to coursework, duration,
so the question is that what is the difference in terms of coursework, the duration of the course, placement, and the project type in PhD, Masters, MTech?
So typically, I can maybe start off with the coursework. The MTech students, I mean, if you look at the different departments, there may be some variations, but the course framework is very clear. At least in terms of MTech program, typically you are expected to do roughly about 40 credits of coursework. So the courses in IISc, each course may be 3 credit, 4 credit courses, graduate level courses, postgraduate courses. So you are expected to do roughly 40 credits of coursework, and then there will be a project component, which is typically around 24 credits. So these are typical numbers, and from department to department, there can be variations. And for the MTech students, they complete the coursework in 1.5 years, and the last 6 months, last 1 year, actually, the thrust will be on the project.
MTech coursework, 12 courses, MS, 6 courses, PhD, 4 courses if you join after MTech, 8 courses if you join after BTech. Typically you do 5 courses in 1 semester, so you can calculate the duration. Placement wise, placement is the last thing ISC students worry about. I hope this statement makes it clear about what the placement opportunities are. Students in ISC basically think of many other things, and placement is the last thing to worry about. Project, again, it all depends on areas, groups, faculty. So it's a completely diverse thing. It cannot be classified as PhD, MS, MTech, but typically MTech projects are fixed duration projects. MS projects are also fixed duration projects in some sense. Whereas PhD is, as I said, is a training program, is not a project per se. So it all depends how fast you can demonstrate your ability to do independent research. So the next question is for students who want to work in roles offered in MNC about nanoelectronics such as Intel, TSMC, Samsung. What will hold them back in India after PhD? I'm talking about working in leading edge technologies such as transistors. Well, it's completely, I think the question, the sense of the question is that these are some leading edge technologies. So what will hold them to stay back in India and not get to the headquarters of these companies? Whether you stay back in India or you take up positions abroad, that's completely your choice. ISC prepares you to an extent that is parallel to any best institute in the world. And when you are trained to that stature, that level, you will have opportunities from around the world. Now, when you have opportunities from around the world, it is completely your call to decide whether you want to stay back in the country or you want to take up a position elsewhere, depending on the opportunities, right? So many of us basically spent a good time in US or other part of the world and decided to come back for our own calling. So, at the end of the day, it's your own calling, what you want to do, and where you want to do what you want to do. So I left Intel to join ISC. I left Intel to come back to India and join ISC. Can we know about part-time PhD?
So I think this question has been answered by Mang before. So the only way we can enable part-time PhD is through ERP program. And so here there are certain rules which are publicly available. The rules are I think summary of the rules are that the company should give you leave for 1 year so that you're physically present here. And there should be some advisor from the company side. And so that's about it. And after 1 year, you can go back to your company and contribute both to your company and also your thesis. I'm not sure this is information enough, but this is what we have now. So ERP is the only way to enable this part-time PhD.
Can I request you, Chiru, to take the next two questions as well? How do you select candidate for PhD at ISC? And how can we apply for PhD at ISC?
Okay. So how to select candidates at ISC, right? So very good question. So currently we are preparing ourselves to interview some candidates in November. So you can still apply to our program. Go to ISC website. So you'll see admissions, and there are clear instructions to fill up certain forms and etc. I think that's very easy to follow. Please do that. If you do that, then once you've given your application, then each department, according to the criteria the department chooses, will shortlist a select set of candidates. The candidates will then be called for an interview or a written test, and this varies from department to department. For example, in CSA department, if you are shortlisted for interview, the candidate has been tested or will be asked to choose a stream that is either computer systems and software or intelligence systems or theory, and appropriately there would be questions asked. And the questions are often in our department. We often stress on the foundations. It is perfectly all right to say that I do not know advanced topics. I only know foundations, but I'm pretty strong in that. Those are the candidates we are looking for. So basically, we check for basic curiosity and expertise and mastery at the undergraduate level. And if you're masters and if you already have a good master's degree, that's even more plus. So this would be the way we select our candidate. And sorry, Mike, what was the second question again? One was how do you apply, another was how to select candidates. I think I covered both the questions.
Yeah, you covered it. There's one more question if you want to take up. If I'm planning for a PhD after 2-3 years of industrial experience after MTech, what are things to be kept in mind? How to be updated in the desired field of research while doing industrial job?
Great question. We all have our own views. So my research area is in machine learning. So my answer would be tuned towards that from that perspective. So what I've found is that often most of the jobs which are offered here, often the so-called formal skills, proving theorems, computing, looking at papers, etc., are often not used, and hence, in 2 years' time, some of these good, strong academic foundations tend to get lost. So that is one case of worry. So jobs, especially which has a large software development component, actually causes a lot of, if I may use the word, decay in your academic credentials, and that can be very bad news for PhD. However, if you're in a job where you're constantly reading papers, implementing them, that is exactly the job profile which would definitely motivate you to do PhD, and it prepares you well. So this would be my suggestion, that if you're planning for a PhD after 2 to 3 years, please keep in mind that even if you do not, especially topics, if you're in machine learning, for example, if you're doing you should keep abreast of yourself of your basic like GATE syllabus level mathematics subjects. You should have familiarity with that. But if you're already doing a research level job, I think you're very well fit to walk into a PhD program. But having said that, there is definitely a lot of merit in having an industry exposure, because there, especially in machine learning, that's where you see the real excitement. So definitely our industry experience is very good. Modulo that you should keep up your basic academic skills. By the academic skills, I mean the formal subjects like mathematics, statistics, etc. What is the other question, Mayank?
Yeah, hi, Chiru. Thanks a lot. You answered it well. So there are other questions which are quite related, and I'll just read it for completeness. Can I pursue PhD after 2 years of break from my studies? Yes. What are expectations from an MTech student wishing to pursue PhD? Chiru has very well covered it. Hello, sir. What pre-work a person from industry should be doing before joining the PhD course? That's exactly what Chiru was explaining. That may vary slightly from area to area, but it's very well covered by Professor Chiranjeev. The next question is, if a person decides to stay back and work in academia in India, if not for industry, if not for institutes that are a handful in number, where else can he get fund to conduct independent research, and what would even drive him if not for industry academia collaboration and facilities? Let me try this question. I think the question is that if the person joins academia, and if this is not an academia which is the top institutes in the country, from where you get the fund, and what will be the driving factor you to stay in those academic institutions which sound like tier 2 academic institutions. Well, the drive is completely yours. Let me come to the funding part. There's several funding opportunities, and among the researchers and often faculties in tier 2 institutes, there's a myth that the funds are often biased and available only for top institutes. Many of us have been into these committees, and we can tell you that these funding allotments are highly competitive, and they go through a rigorous screening and evaluation process. And in that screening and evaluation process, nobody looks into your affiliation. Of course, there's often a correlation between your affiliation and your how good your CV is. So people often miss out the CV part and often correlate with the institution, unfortunately. But the fact is that one would look into the proposal and one would look into the CV. So the CV tells the promise of the individual to deliver the promise. or the confidence that the funding agency gain in terms of the individual being able to deliver the promise given in the proposal. And the quality of proposal tells how much advancement in the state of the art will happen if that proposal is pursued or executed. So if you have written a good proposal, and if you have carefully built your profile by taking up every opportunity that comes in front of you from the initial stage, right, after certain time you will not feel that your proposal has been kicked out. You will have funding available if you are doing well, and if you are writing good proposal. It's an exponential path. So you do well, you will do further well, and you will have more and more opportunities. Now if you get into this exponential path, you have a drive. I hope that answers the second part of the question. Please tell about doing part-time PhD, full-time PhD advantage, disadvantage. I think Professor Chiranjeev explained the difference between part-time and the process. Maybe I can request Chiru again to also talk about the difference and advantage, particularly disadvantage.
Disadvantage for doing part-time PhD. Right.
Yeah, advantage of full-time, disadvantage of part-time.
Okay, so I think, so I don't have too many ERP students, but I have a few. As I said, the only way to, at this point, the only way to pursue part-time PhD is through the ERP program. Now, there are clearly, as I've seen over the years, often what happens is most of the students, which I have seen at least, they are a little senior in that sense that, they are family and things like that. They're also a job. So good thing is what I see is that they are much more focused than our usual students who are full-time students. However, our full-time students is perfectly all right to say, I have no idea what I'm going to do research on, let me read lots of papers, lots of books, let me try 5 problems and do. And we welcome that. And that's actually the best training one can have, because after your PhD, you should have not only a good problem to solve, a lot of papers to write, but you should also come out as a well-rounded person who is exposed to many things in that subject. So that our full-time PhD has a big advantage. But for a ERP thing, because of your, because the company would also expect you to do some work because they're paying your salary after first year, right? So often most companies do not leave the candidates alone. So they would, since there is some expectations, so often, unless the candidate is very focused, that is already have a good problem, like in a matured problem, a good direction, that can become a challenge. So those would be in a very high level advantage, disadvantage. So in one line summary, I think full-time PhD allows you exploring many topics, and which I personally think is absolutely essential for a somebody with a PhD degree, right? Whereas part-time PhD, because of the lack of time, by part-time PhD I mean the ERP program, because there is lack of time, it would be good if the candidate is focused. However, there are several examples in our department who has excelled, because they could find time from their work and excelled, and I have worked on, like, not in a focused way, but 2-3 problems, and they have written excellent papers, etc. So there are cases like that. I'm not sure how much this explains it, but I'll leave it there, I guess, in the interest of time.
Thank you, Chiru. So there are some quick questions. Is MTech mandatory for joining PhD program? No, I think we have answered it very well. Do we have to pay huge fees in ERP program if the organization does not fund our fees? I think if I understand the rule correctly, the organization has to sign for funding your fees. But fees is whatever is the fees has to be paid, and this fees is higher than the regular PhD candidate who pays from their stipends. Vishnu, you want to take this question? What happens to all the research work after it's published? Like, what happens to all the papers after they are published? Who actually use them?
Yeah, that's an interesting question. So I'll tell you my take on that. So research, when you do research, right? I mean, whatever be the research, you're always standing on the shoulders of giants. You're always looking at what others have done, and then that gives your work. So in that sense, I would say published work provide right results. So it is going to be useful to the future researchers in the field. So they are going to look at, let's say you might have used some particular type of experimental technique, or you would have come up with you would have proved a theorem in a particular way, and somebody might use that result as an inspiration to find out something new. So all the published research, it will have its own use. I think that is my take on that question.
Maybe we can have everyone's view here. Vishnu, your voice was breaking a bit. Maybe we can also have Sudan. You want to add to this, and then Chaya?
Yes. Yes. Yeah. So once you publish the paper, I assume that the paper is not patented. But even if you patent and then you publish, then this work can be used by the research community. So in Pacific area, there will be more than 1,000 to million people who are working in the same direction. So so if your work is very important and very significant, then they will cite your paper. Once they will use your method or your work, they will cite your paper, and then you will be getting those credit that how many researcher cited your paper, okay, and that will add value to your CV and your publication, and that will help to also for your promotion and for when you are looking for job, all these things. So there are so many ways you can get the benefit if your published paper is very good. Yeah, that's all from my side. Hello?
Yeah, thanks, Majid.
Yeah. So whenever we publish a paper, we're basically advancing the state of the art of knowledge, right? We either prove a new theorem that gives us new knowledge, or if it's not a very theoretical paper, you show better way of doing things that is more efficient than how we currently do things. So if you are advancing state of the art in a theoretical way, then you're basically giving other people more tools to build on top of that. So you're contributing to expanding knowledge in some sense. If you write a more applied paper, then there are also other ways of it being used in terms of it actually getting deployed in the real world, it contributing to its use in the industry. For example, in computer science, if you come up with new algorithms for very relevant problems, or in cryptography, if you come up with new cryptographic schemes, today there is a lot of scope for it to be already deployed. I mean, this was always true. It's just that there used to be a time lag between, when you make a certain contribution and when you can actually see that implemented in society. And today, I think that gap is reduced, and you can actually live to see your science making changes.
Thanks, Chaya. Let me just summarize what my colleagues explained. It's a very important question. And often students don't know what to do with the paper, and often students are misled in terms of publication as a requirement, but you don't know what to do with the paper, what to do with that publication. So thanks for asking this question. I would put in this way that, what is your paper? What is a paper? Paper is basically, your communication about the advancement that you have done in a certain field of science or engineering. Right now, that advancement is based on a problem statement that you pursued and you tried to solve. So basically, your paper talks about a certain way of solving a problem, right? There may be many ways of solving the same problem. There may be many views on the same problem. You are communicating your way of solving that problem, or elaborating that problem, or even understanding that problem better. Now, how the problem originates, right? Now, the problem may originate from, say, something which is pertinent within industry, something which is highly in demand within industry and pertinent and pressing within industry, and then through your peers and community and through other papers, you get to know a particular problem that the world is trying to solve. That's one. The second is a problem could be extremely fundamental in nature, say understanding certain aspects of the nature or the universe. It could be physical science, it could be biological science, it could be mathematical science and whatnot, right? Chemical science and whatnot. right? So basically you're trying to understand the certain property or uniqueness of the nature which has not been explained or elaborated before. So that's also a problem statement, right? Now the third type of problem statement could be that say a community or a group of people have come up with certain predictions or projections for tomorrow, that tomorrow the world will be of this kind in terms of science and technology, and you are trying to basically develop that idea further by either pointing out certain problems that the world need to address, or by working on those problems that the other colleagues would have pointed out, that if this field has to evolve or develop, you have to work on these problems, right? For example, quantum technologies. These are areas where the problem has been originated from the vision that the community has projected, right? So now this gives you the problem. Now if you have solved that problem, right, the solution or the paper goes back to the same community which has basically given that problem, and now that community could be your academic circle, it could be your industrial circle, or it could be your other scientific community or colleagues who were posing those problems, or who are parallelly working on those problems. So either it can result into advancing the state of the art in terms of technology or understanding of the nature or science, right? And as some of my colleagues pointed out, that when people cite these papers, that you also get noticed, right, as a result of that. Right, but fundamentally the paper goes back to the same community which has posed the problem to the community. So you want to add something to this, or we move on?
I think let's move on, because I think all the points are covered. Let's move on to other things, right?
So what are the requirements for joining direct PhD without masters? I think this has been quite well explained. Either you come through the gate route, or you should have more than 8 CGPA in BTech if you have done your BTech from a CFTI. Chiri, you want to take this question?
What do you do from here after the meeting, right? Good question. Immediately after the meeting, you should have your dinner. No questions about that. But I think, the interesting thing is, yes, in ISC, there are opportunities, for doing, internships after during your BTech, but unfortunately, you don't have a good structured program. So often it is, you can write to, look up professors' websites and see if the things which you want to learn about and want to do your dream projects about is aligned with the professor's interest. Do write to the professor. I'm sorry, if you don't get any response. If you don't get a response, not the person is not interested, but it's just that they do not have any positions open. If the positions open, they'll definitely get back to you, and that can be one way of interacting. I don't know what else to say. Yeah, but we welcome these young minds.
But dinner is mandatory.
Right, dinner is mandatory. Yes, of course.
Chiru, can I request you to put a closing note?
Thank you, Mayank. So good evening, and to all of you again. So it's been a pleasure, having this session. I wish you could have it a little bit more at the personal level, where we could also hear you speak. But given the constraints of the times, I think this is better than nothing. So over the last few years, we have seen that people, legitimately so, are especially young minds, are in two minds in pursuing higher studies. So all of you, as you see, India is a growing country, and India is changing for the better in many ways. So and a hallmark of a modern advanced country is the level, is the intellectual capabilities of the population. And PhD and India probably needs many more PhDs than we have. But PhD is just not a degree. It also is a process which will help us, tackle the problems of the day better. And in ISC and other institutions as well, we try to do our bit. And this is one of the many programs where we will try to engage with you, have dialogues with you, to see if to convince you, not to force you to come to ISC, but just to have a dialogue and understand that what are the challenges and opportunities in PhD. With that spirit, we have designed this meeting. I would like to thank all our student participants. They did a wonderful job presenting their life's journeys. I would like to thank also my faculty colleagues. And last but not least, I would like to thank all of you participants who have taken the time off and come here to interact with us. And those of you, if you're convinced about doing a PhD, we still have our forms open. Please apply. Last date is 31st October and for the November cycle. So with that, I would like to close by saying thank you. Yeah, that's all I have to say.
Thank you, Shiru. Thanks, everyone. I think we can close the call formally.
Thanks a lot. Bye-bye.